Now we get into the roof systems. So far, we've mostly seen Amvic depicted in floor applications, but this product line is much more diverse than that. Amvic can be used for roof applications as well, and that includes both flat and sloped roofs. When looking at a sloped roof application, there are a few things to keep in mind. For shallow slopes, a 5.5 slump is fine, but going to a 4x12 pitch, the higher slopes, you'd want to reduce the slump to 3" to ensure the concrete stays where you put it when you pour it. We generally don't see slopes exceeding 30 degrees with the Amvic and would not recommend going higher than that either. Amvic can be configured in various roof types. The most common ones are gable, hip, single slope, shed style. Having said that, a cholesterol roof can be relatively easy to build as well. Butterfly roofs and attic style roofs are also possible. These diagrams show how Amvic forms would be stacked in gable and hip roof configurations. The parts highlighted in red are the parts of the structure which will be supporting the loads from the roof. For the gable roof, the ridge beam at the top and the ICF walls perpendicular to the Amvic concrete joists make for the roof load-bearing components. For the hip roof, it's a bit more complicated. At the top, we still have a ridge beam with 4 hip beams connecting to it. In this configuration, the Amvic concrete joists are equivalent to the jack and common rafters found on wood roofs. For hip roofs, the top portion of the entire ICF wall is often designed as one continuous edge beam to help take the load from the roof. This would be reflected in the rebar configuration at the top 1 or 2 courses of the wall. Working with single slopes is much easier. Both the shed style and cholesterol style roofs are quite popular for passive solar designs and can often be seen in high performance houses such as net zero and passive homes. The supporting of the roof is quite straightforward. With the single slope and the cholesterol, the wall in the middle would need to be designed properly. Butterfly roofs are essentially the inverse of a gable roof with a ridge beam and 2 supporting sides. This style of roof is only recommended for the warmer and drier climates for the most part where you have very little precipitation. The easiest configuration for Amvic is to build it flat, like a floor, and then add framed wood in whatever shape or style you need or want. This is probably the easiest and most simple build, but would be the most expensive. When working with a sloped concrete roof, the soffit becomes an area that should be given some attention to ensure that it's detailed properly. In this slide, we're seeing a soffit condition where the Amvic concrete joists are perpendicular to the wall. In the next slide, we'll show the condition when this is parallel. In a nutshell, there are 3 main configurations to work with. The left version shows just a thickened edge slab extending past the ICF wall, which is fairly easy to frame around. The right version shows a frame soffit, which is also straightforward. The middle condition, where the Amvic block forms part of the soffit, is a little more complex, and we'll provide an example in a few slides. In this slide, the soffit condition is for when the Amvic concrete joists run parallel to the wall. All 3 conditions show this. You can see the slope by looking at the shadows on the walls. The left version shows a thickened edge extending out, similar to what you have seen in the previous slide. This type of configuration is limited in length. On the right, you have a framed soffit, which is also limited in protrusion length. The middle condition is the most complex. As you've seen in all the slides up until this point, Amvic generally runs in a single direction. You can have multiple spaces or spans, but within each span or space, Amvic will run in a single direction. In situations where you would want to have a bigger overhang, the Amvic system would need to be stopped short of the wall. There would be a beam, concrete or metal, and then Amvic will span from that beam to the wall perpendicular to the rest of the system. Here we have an example of a finished soffit where Amdeck is protruding past the wall. There are multiple ways of finishing the soffit with Amdeck, and this is only one. But it is important to detail this condition properly and not leave it to the contractor to figure out on site. In this particular rendering, there's additional insulation attached to the bottom of Amdeck, which makes this a cold roof, but you would easily add rigid foam insulation above the concrete as well. When using Amdeck in a sloped roof configuration, you're essentially creating a cathedral-style roof, and it is highly recommended to make sure you have venting capacities within the roof assembly. The air cavity helps cool the roof, which is beneficial in all climate zones. Flat roofs are much simpler to erect, but they still require a degree of knowledge to make sure that they're done properly. This would be applicable to both residential and commercial construction. The slump for flat roofs would be around 5.5, similar to floors. Flat roofs are actually low slope roofs and do require a minimum slope of 2% and generally up to about 7 degrees. After that, they would be into the slope roof category. The slope can be achieved by sloping the concrete with a concrete topping. In some instances, the rigid insulation is sloped, or the entire Amdeck system can be sloped, but that might be a little more difficult. Since Amdeck creates a concrete surface above it, virtually any configuration of flat roof can be done. Conventional or inverted membrane can be done. The membrane can be adhered, ballasted, or mechanically fastened. All the common roof membranes would be compatible as well, regardless if they are single or multiple ply. If you're looking to overhang or create a soffit with your flat roof Amdeck system, the methodology is very similar to what we have seen in the slope roof soffits. The left condition shows the overhang framed with Amdeck, and this would also be applicable to balconies. The middle condition shows the thickened slab protruding outward. This would be limited in length. On the right side, there is no overhang with the concrete or the Amdeck with the concrete. This type of condition can be done to achieve a no parapet look that might be needed for a particular design. Alternatively, a soffit can be framed and hung from the wall, which will act as an overhang. Depending on the size and exact configuration, the framing can either be attached to the ICF webs or to the outer ICF panel and can be stopped short. The framing can be attached directly to the concrete also. In most cases with flat roofs, we see parapets, tall or short, and everything in between. The main takeaway points from this render are the following. Additional insulation can be added below the Amdeck system. This will make for a cold roof and would probably be more common in residential construction. In commercial construction, adding rigid foam above the Amdeck system is more common. The foam will create a sandwich-like system, very similar to ICF, and oftentimes the foam is used to create the slope for the drainage as well. When using an ICF parapet, we recommend covering the top of the parapet with rigid foam. This helps ensure the thermal envelope continuity and separates the wood trim from the concrete. Covering the foam with a sheeting board is important, especially when dealing with roof membranes that need heat, such as a BUR roof, or even single-ply roofs with welded seams. But we highly recommend working with a roofing consultant to figure out the best configuration for your specific project. To close off on this, all the typical flashing, counter-flashing, overlapping principles that are needed for a typical flat roof would apply here as well.